Again, we want to continue the part 2 of the limits of functions. Now, we consider like 4 rules in our previous class. In this class, we're going to look at the remaining rules. So let's start immediately with this. That's number 5. Under that, we are going to look at the product of functions and how we can treat the limit of such functions. Now, if we have a limit, if you have limits of function of x as x tends to c to be equal to m, and we also have another one where limit of g of x as x tends to the same c to be equal to n, then we can obtain the limit of function of x tends to c times, let's put times there, limit of g of x as x tends to c to be equal to m times n. That is, whatever the result of this one is, and the result of this one is, which is m and n, then we just multiply the result to give us the multiplication of the functions. As simple as that. Yeah. For instance, let's take an example. That's the rule. Now, let us take one example under that condition, under that situation. Now, if we have limit 7x plus 1 as x tends to 3, to multiply limit of 3x plus 1 as x tends to 3, and both of them tends to 3. We simply find the result here. The result is going to be equal to limit of 7x plus 1. As x tends to 3, 7x becomes 7 times 3, and that's 21. Now 21 plus 1 is 22. Then times. Now as x tends to 3 also, 3x becomes 3 times 3, which is 9. 9 plus 1 is 10. So we have 22 times 10, which is 220. So that is the limit of that function. That is the limit of that function. As simple as that. We just multiply the result of each limit. Now, the 6th condition is an F under limit derivative and limit of functions. When we have limit of function of x as x tends to c to be equal to m, and also we have limit of g of x as x tends to c to be equal to n, then we can obtain the division of the two functions. We can obtain the limit of the division of the two functions. Then we say, then limit of function of x all over g of x as x tends to c will be equal to m over n. As simple as that. It will be equal to m over n. So that's the rule. We have limit of function of x to be m as x tends to c, limit of g of x to be n as x tends to c. So the limit of function of x over g of x as x tends to c will be the result of the first one over the result of the second one. For example, let's take one example under that. We have as an example, we have limit 3x squared minus 4 all over 2x plus 1. Now, as x tends to 3, now let's put in brackets, that's the question. Now, the answer is going to become limit of 3x squared minus 4 as x tends to 3 all over limit of 2x plus 1 as x tends to 3 as well. Now, what do we get there? As x tends to 3, x squared becomes 9. That's 3 times 3. That's 9. 9 times 3 is 27. So we have 27 minus 4 all over limit of 2x plus 1 as x tends to 3 becomes 2 times 3 is 6 plus 1. That's 6 plus 1. So we have 24 minus 7, that's 23. 27 minus 4, that's 23 all over 7. So that's what we have. We can simplify as 3 2 over 7. So that is the limit of this function. We derive everything, and eventually we arrive at 23 over 7, which is an improper fraction, and further simplified to a mixed fraction. Finally, on that category, we take we're going to take the last condition. We are taking the last condition on the limit of functions. Now, that is when we have f of x. We have f of x over g of x. Let me write it over. We have limit of f of x over g of x as x tends to c to be equal to 0 over 0. Then this is indeterminate. This is indeterminate. It is unreasonable. So we have to apply log Peter rules, Peter's rule, okay, to further simplify this, to make it determinate, because it is indeterminate. So we now make it rational using L'Hopital rule. What does the rule state? The rule states that that the limit of f of x all over g of x as x tends to c is also equal to limit of f prime of x over f prime of x over g prime of x limit as x tends to c. So it's the limit of f prime of x over g prime of x as x tends to c. So that is L'Hopital rule. Now we will use that to solve problems that are indeterminate or unreasonable in nature. Now let's take an example. Now, if we have to find the limit of x squared minus 9 all over x minus 3 as x tends to 3. Normally, if we just put 3 in there, we're going to have x squared minus 9, that's 3 squared, that's 9 minus 9 all over 3 minus 3, and that gives us 0 over 0. This is irrational. This is unreasonable. It's indeterminate. So we have to use L'Hopital rules to tackle this problem. So solving it, now what we are going to do is, we now say this is still going to be equal to limits of, when we differentiate this, we have 2x minus 0 all over 1. Going through, we have this as x tends to 3. And then we have 2 times 3, that is 6 over 1. Our answer is 6. So that is how to differentiate functions of this nature. Please take your time to go through the part 1 of the limit of functions, and also go ahead and solve more problems on this topic. Thank you very much. I wish you all the best.